Hello everyone, you're welcome to my class. Today our topic of discussion is force. In our last class we stopped at the types of motion, where we discussed random motion, rotational motion, translational or linear motion. We have relative motion, we have oscillatory or vibratory motion. So there we said the causes of motion is force. And I briefly said that the forces are divided into two. Today we are going to see in details these types of force and there are various examples. So as I said, the topic of discussion is force. So what is force? I believe if you are hearing this word for the first time as an SS1 student, what comes to your mind about force, because it's an everyday words that are being used. A force, when it says somebody is forced to do things, meaning that he or she was asked to do things out of his or her will, right? But in physics, the word force is very, very different. So force is an external agent that changes or tends to change the state of rest or of uniform motion of an object in a straight line. Tend to change the state of rest or of uniform motion of an object in a straight line. This is telling us, like I said in our previous class, that forces cause motion and it also prevents what? Motion. Is that correct? It's an external agent that changes or tends to change the state of rest or of uniform motion of an object in a straight line. Is that clear? So that is the definition of force. But literally, some people just normally say that force is a pull or push. Yes, force is a pull or push. But that pull or push just falls into the categories of force or forces, which we are going to learn today. Are we clear? So very importantly, force is a vector quantity. I believe you have heard vector quantity and scalar quantity. Vector quantity are those quantities that has both magnitude and direction. It's directional sense or directional wise, meaning it has size, right? It has size and it has what? Direction. If I push something away from myself, that away is a direction, and the amount of force I apply in pushing is the magnitude or size. Are we clear? And the SI unit of force is Newton. Capital letter N. Please don't use small letter n. Right? And the derived unit is kilogram meter per second square. This is derived from the famous formula that F is equal to ma. So the unit of m, the mass, is kilogram, multiplied by the unit of acceleration, which is meter per second square. That's what gives us kilogram meter per second square. So force has effects. The effects of force, number one, is that it can change the speed of what? Of an object. So I can apply force to increase the speed of object, or force can also be applied to decrease the speed of an object. Also, other effect of force is changing of what? Direction of the movement of an object, right? You can apply force to change the direction of what? Of a moving object. And the last one is apply force to change the size and shape of an object. Changing the size and shape of an object with the help of what? Force. Look at what we have here. This is a spring. Here, force is applied to increase what? The length of this spring. At the same time, force can be applied to decrease the size. By what? By squeezing it or compressing it. Look at the rod here is straight, but with the application of force, it's now bent, right? We can also apply force to squeeze, right? We can also use what? Hammer to hit it, to squeeze it to this shape. Are we clear? Now, types of force. We have contact force. From the word contact, I believe you know it means something that what? Involve touch. Right? It involves touch. You have to what? Hold it or get hold of it before the force can be applied. We have what? Force field. This involves the application of force without what? Without contact, right? Without what? Contact. Force field. The field here is not the field where you play football. It's a region or in space where what? Where forces are experienced. Are we clear? So those are the two classes of forces we have: contact force and what? Force field. Okay. The next, let's take it one after another. What is a contact force? This is a type of force that requires direct contact between interacting bodies. Direct contact between interacting bodies. Take, for instance, you want to open a door to the banking hall, that type of their door. Some of them is either you push or you pull. So in order for you to be able to open the door, you have to get hold of it. You apply a force to open the door. That type of force you applied in opening the door is an example of contact force. That is why I said push or pull is an example of what? Contact force. Examples: frictional force. Frictional force is said to be an opposing force that tends to prevent the relative motion of a body, of two bodies, in contact with surfaces. This we are going to learn it in details in any of our classes. So when you rub your two hands together, the kind of force that you experience there is what? Frictional force, which result in generation of what? Heat. Are we clear? Because two bodies are rubbing against or are rubbed against each other, and it results in what? In heat. Are we clear? Okay, the next one is normal reaction. Whenever a body is placed either on top of a table, there are normally two or more forces that act on it. Yes. If it's at rest, we have two forces, such as the normal reaction and the weight of that object acting downward. Are we clear? So that normal reaction too is a contact force, because there is a contact between maybe the object, let's say for instance, a textbook on top of table. Then there is a contact between the surface of the textbook and that of the surface of the table. So the normal reaction there is also an example of contact force. And the weight acting downward. Those are the two forces that act on a body at rest. Then the next one is tension. These occur either in a rope or in a string, as the case may be. Are we clear? It is also a force that acts in opposite direction to the weight of an object attached to the rope or the string. The next is spring force, just similar to that of tension. Are we there? So these are the types of contact, examples of contact force. Okay. The next is for you to see what I'm talking about. You see this man here trying to push the wheelbarrow. What the man is doing now is a typical example of of contact force. His hand must be in contact with the hand of the wheelbarrow before it can push forward in this direction. Are we clear? The next one is a pull, right? This man is pulling this using using this rope. Now, let me remind you quickly that in this particular situation, we have a pull and at the same time we have a tension in this rope. So tension is acting, if this is the rope, tension is acting in this direction, while the weight of the little girl is acting in this direction. Are we clear? So these are push, this is push, and this is pull. So quickly, you know that push is away from yourself, while pull is toward yourself. Are we clear? Still on the examples of contact forces or contact force. Here I have talked about the push away from yourself. See the arrow? This is the direction of the motion of this object, and the object is lying on the surface of the floor, right? So there will be existence of frictional force. The frictional force, I told you, is an opposing force. It always acts in opposite direction to the motion of an object. Hence, you see, as this little girl is pushing in this direction, the friction exists between the surface of this object and the floor, which prevent the free flow movement of this object. Are we clear? So here there is contact. So it's an example of contact force. Similarly, you see here, this is the textbook on the table. And I told you when the textbook is at rest, which is the object here in the case of this, then there are two forces, which is the normal force, or we call it normal reaction, and the weight of this object. We calculate the weight of this object as, you use W to represent the weight, is equal to mass of the object times the acceleration due to gravity. So know it that W is nothing but mg. W is equal to mg. So it depends on what happened. When you apply this force to push it in this direction, I told you frictional force is always in opposite direction. Are we clear? The next one is force field. This is the force that acts between two bodies that are not in contact. It's very simple. The forces that act between two bodies that are not in contact is known as force field. And I told you that field is not the one you play football, isn't it? Field here is a region. Is a region where forces are experienced, right? So field is a region where forces are experienced. We are going to talk about the forces that you can experience in field, not all forces. Are we clear? Examples: gravitational force, magnetic force, electric or electrostatic force. Now, this is gravitational force. This is an apple falling freely under the influence of the gravitational field. The Earth exerts this gravitational force on what? On the apple, right? That is why as it ripes and falls, it does not hang in the air. It falls to the ground because of what? Gravitational pull of the Earth exert on it. Are we clear? So still on what? Force of gravity. When you jump up, you come back to the what? To the Earth's surface, to the ground. It's as a result of what? Gravitational force. A fruit falling, you throw a stone up, it comes down, is as a result of what? Gravitational force. Now here is magnetic field. You can see that this is the bar magnet and this is a metal at a distance being attracted even though they are not in contact. This region around the bar magnet where the force, the magnetic force is experienced is known as field. The region where the magnetic force is experienced is known as a magnetic field. Are we clear? So probably if you take it farther away from from the bar magnet, you will not experience any force. You can try this at home. Take a bar magnet, bring a nail or any metal close to it. The closer it is, right, the more the attraction force. And the farther away it is, the lesser the force of attraction of the magnet. Is that clear? Here is that of electric field. This is as a result of the acquired electrostatic charge from the what? From the dried hair when the comb is rubbed vigorously over it. Are we clear? So this is a form of electrostatic charge. When you rub your hair with the comb becomes charged, and as a result, it attracts what? A pieces of papers. You can also do that using what? Using your pen, your biro. Use it to rub over your dry hair vigorously and take it close to what? Close to a piece of paper. You see that it will attract this piece of paper as a result of what? Of electrostatic field, right? It generates field around the comb that got attracted by what? By the piece of paper. So these are the examples of a force field. I hope you understood our explanation. What are you expected as a student to know in this particular topic first? Very important. You are expected to know how to define force, know the unit of force, the SI unit especially, which is Newton, and know the derived unit as well, kilogram meter per second square. After this, you should be able to know the types of force, which are contact force and force field, as well as their various examples. This is all you are needed to know in this topic if you are preparing for exam or test.